Our first pitching session going to be on topic of machine learning, AI, big data. I'm asking everyone with the blue investor tag to take seat on the front row of front tables, and also asking Angelo del Priore, Upal, Basu, Aaron, Jacobson, Anis, Uzzaman, Ashmeet, Sidana, and Geoffrey Baehr to take seat on the stage. We start our panel from discussion between our investors and Jeff. We asked Jeff to moderate this discussion. Jeff is a general partner at Almaz Capital. He investing in the areas ranging from security, networking to analytics and big data. Geoffrey was led investment in Viata, which was acquired by Brocade in 2012, as well as Sinara, GridGain, and Scale, where we hold board seats. Okay? And we have about 20 minutes for discussion. And after that, we'll start our pitching session.
Okay.
Your stage.
Okay, thanks, guys. So I'm Jeff Baehr. I'm from Almaz Capital. I also work part-time as a VC and part-time as a CTO for a couple of long-suffering companies. And I want to thank Steve for not going on about machine learning so that we can look intelligent. But I got to tell you guys, there's only one sentence that counts. Bet the farm. I was over at Google a couple times this week. They're betting the whole joint, everything, on machine learning. I was over talking to some Microsoft guys. They're betting the farm on machine learning. So, you know, what is machine learning? Essentially what it is computers teaching themselves how to program and how to write algorithms and making themselves better at doing it. So I'm going to ask some questions which hopefully stimulate some discussion, but I want to give you guys a sense of the magnitude of what's going on. So I don't know if you guys all know this, but guess who's an endangered profession? Software engineers. Because guys who write low-level code, adios. You guys are going to be out of a job unless you start getting seriously good at writing seriously good code. Do you know that Google is mining GitHub every day? You know that 4.5 million open source projects have been scanned and sucked into their open source machine learning algorithms so they can start to write code. 8 billion lines of code is sucked in and is being examined right now to go write low-level routines. And as Steve said, the hot action in programming is not writing low-level programming. So one of the professions that's at risk here is not sophisticated engineers. So what I'm going to do is I'm going to ask the guys here, rather than me talk the whole time, I'm going to ask them to comment. And the first question I want to ask is, my company, among many other lemmings, I mean VCs, has invested in machine learning chipsets. And this is one of the hottest things in venture capital right now, which is throw vast quantities of money at companies building silicon. There are 55 companies that I know of, which means there are probably a lot more, that have received a lot of money to build specialized silicon. And you know, 2 years ago, if you said to some VC, we're going to build silicon, the answer is, oh, go away. But today, if you say, I'm building specialized silicon, you get a lot of money. So of those 55 companies, 5 of them have received more than $100 million, not necessarily in the first go-round, but that's a lot of money. And that's a lot of people doing stuff. So I'm going to sit down, and the question I want to pose, first question I want to pose is, have we overcooked it in investing too much money into specialized hardware for machine learning? And I'll just open it up to all you guys, and I'll sit down. Go ahead, don't be bashful. My take is yes. 49 of the 55 are going to go away, and there are going to be a lot of investors who say, gee, I probably shouldn't have done that. So, contrarian position, if you wish.
I'll take a contrarian position from the long-term perspective. In the short term, yes, Silicon Valley always over-invests in anything that has the potential to disrupt. There are always late followers who will throw money in. So in that sense, yes, I agree that 49 of those companies will go away. But are we at the dawn of when we will see significant innovation in hardware where are we at the stage where I expect fundamental changes to come about in computer architecture? Unequivocally, yes. And if you want someone much smarter than me to talk about it, go attend the Turing lecture, which is coming up from some of the pioneers of computer architecture, Hennessy and Patterson, who wrote the defining textbook on computer architecture, who are going to get the Turing Award this year, who will be speaking just in a month from now. And that's the magic of Silicon Valley. We are definitely at the dawn of an entirely new way of thinking about computer programming, software development, and all of the areas which it can disrupt that Jefferson was talking about earlier, which is all going to enable new startups to happen.
Yeah, I mean, I would also agree that we're at the dawn of a new revolution in computing architectures. You need to rethink how you do processing and neural networks in order to be able to scale machine learning and AI effectively. I do think that having 55 companies doing deep learning chips is a bit much. You just look at who the customers are going to be. It's most likely going to be the Amazon, Googles, the large cloud players of the world, and actually a lot of them also have their own deep learning chip innovation teams themselves. If you look at any major semiconductor markets, there's typically only 1, 2, sometimes 3 lead players, and so it makes me think that 55 is too much. There will probably be 1, maybe 2 new innovators in the AI chip world. And hopefully they actually don't end up being acquired by the Intels and NVIDIAs of the world, which have a lot to lose if there is a new startup that is able to build an independent company in the space.
Yeah, so a slightly different view. Chips, there's always this Cambrian explosion of possibilities, and obviously in a perfect world, a bicycle would have a different chip than a satellite, than a car. And what we have seen is it's very expensive to, even though the technology may be unique, distribution is very hard in the chip industry. By the time you actually have a scalable business, you usually get acquired by one of the Broadcoms or the Intel. So remaining independent is hard. $100 million, I know seems high, but in the software world, bicycle companies are raising more than that. So, so to me, that number itself is not intimidating to SoftBank, for example. We, for example, not taking away from the innovation in hardware, what we see is software keeps on accelerating, and software engineers tend to be extremely creative. So, for example, we just backed a company in Seattle called XNOR.ai, which is trying to run AI on Raspberry Pi and commoditized hardware. So I'm not questioning that better hardware leads to better outcomes, but software engineers can seem to extract value from commoditized environments constantly, and we think that trend will continue. So
let me jump on that just for a sec. You guys all know that there have been things like crypto accelerators, SSL accelerators, SCSI accelerators, and they've all failed. And the reason is by the time the silicon comes out, the software is way ahead of them. So right now, if you're a machine learning guy, you're fooling around with PyTorch and Onyx and all the other Cafe2 and all the other frameworks. So one of the worries, and I'd address this to all of you, one of the worries that we have is by the time that really complicated piece of silicon comes out, 18 to 24 months from now, the software is going to be way ahead of it, and it's not going to match. And we're going to have a big problem. Because the software, so the question I'd pose to you guys, is the software on general purpose, semi-specialized chips like NVIDIA and all, is that what's going to beat or possibly kill all this specialized work going on in ML?
I think there's always going to be this demand for specialized needs, and there's always going to be a mismatch between the software and the hardware development, and it's happened for the last 100 years, and it's probably going to continue to happen. It's just the process of the engineering is harder on the hardware than it is on the software, and the ability to iterate on it, I should say, is a lot faster on one versus the other.
Agreed. And so one of the things that we see a lot of effort going into is writing code. So machine learning code helping to write other code. So the question that we've got is, A, are we putting ourselves out of business as engineers, which certainly looks like it. And if you talk to Peter Norvig or Jeff Dean over at Google, and this is not name dropping, just these are guys who really know what they're talking about, they have code that is writing a lot of low-level code to run the show. So the question here is it too early for all of us to invest in automated code writing? Is it time for us to invest? Is the vision of what we know as a software engineer going away? is for you guys to remain relevant, skip all your compiler work and just get into using ML frameworks? What do you guys think?
I think the time to invest in automated code writing actually is now. I mean, the good examples, we've invested in a company called Instabase. And what they've done is created software that automatically writes a lot of the ETL and data munging that happens to be able to clean up and take data and get it ready to actually do any type of machine learning and AI analysis. I think it's important actually to do investing in very specific types of applications and use cases. I think it's going to be a long time till we see generalized, general purpose code writing. But if you pick a specific use case, it could be data munging, could be some type of process, robotic process automation, integrating applications, connecting APIs. I think a lot of that will increasingly be automated and written by computers.
I also think that these companies that are coming out, right, who are trying to create modules that the engineers can easily use to program AI with, is becoming more and more like generic flow right now. I'm seeing a lot of startups coming out of Berkeley and Stanford who are actually basing on creating modules that the regular programmers can actually use to actually create the advanced AI programs. I think it is a norm in the industry that we have seen in other areas as well, and it is becoming more and more common in this area. So Fenox, we have invested in many AI companies. I think some of the significant ones are X.AI or Affectiva or Jibo. We are major investors in these companies. And this is one of the areas that we are looking deeply, and we're investing in some of the startups in this area.
So the question I have kind of generally for everybody is, so where are the machine learning apps? We're talking about the plumbing that goes underneath the house. That's what we're building right now. But the first apps they're actually already out there. Sure, Pinterest uses machine learning, Yelp uses machine learning, but that's not what we're talking about. So I'll give you guys an example, and maybe you can fill in some examples of where you think the opportunities are. There's a little company up in San Francisco called Almaz. They monitor big electric motors, and I mean big, 25,000 horsepower and larger. So if you're running a refinery, you use these guys to tell you when your motor is going to fail and when it's time to go and put new ball bearings in its races. And so these guys save not the motor, because the motor is irrelevant, but shutting down a refinery costs hundreds of millions of dollars a day. So that's one app. The people who are doing preventive maintenance for airplanes, you don't replace the parts anymore at 600 hours. The machine learning program says this part needs replacing tomorrow. Huge savings. So do you guys have other examples of where you see it coming out? Go ahead.
So there are machine learning apps wherever there is data. The dirty secret of machine learning and AI is that it requires an enormous amount of data. And I'll use this to also answer the previous question that we were discussing here, which is the job of the software programmer going away? The answer to that is unequivocally no. There is an enormous demand for software engineers, and that is only going to continue to increase because the work that was involved in writing programs may transition now to data processing, to thinking about how do you organize data, analyze data, prepare data for that eventual machine learning engine. And so at least for the near term, which I define as 5, 7, 10 years ahead, there's going to be no disruption over there, unless we see some form of creative outcome from left field, which no one can predict. Those things happen in life. The second point I'll make is that the opportunity for applications comes where there is creativity. We are only limited by our imagination in what kind of application we can think of. And if there's an entrepreneur sitting here in the room or here in Silicon Valley or anywhere in the world, if they have a great new idea with software, with things like cloud, machine learning, etc., you have a lot more tools available to you and you'll see them. And so I'll end with an example. I have a company which I've invested in called Scale. I was the first investor. They run on Amazon. It's a machine learning company. What do? They help you run Amazon on Amazon. Now talk about being recursive. This company is growing exponentially because they have all the data. The data comes from Amazon itself, which helps you run on it. So that's where the creative feedback loops come in, which create venture-style companies. And again, we are not limited to venture style only in this conversation, but I understand that's the focus. We will see those type of outcomes in machine learning where creativity and data come together.
So just one more comment to support that. I'd love if low-level coding became machine, because I gave up computer science because I hated assembly programming. And if machines can do that, I can do creative work. I think if we can be in a world where artists and poets can become programmers, everyone becomes a programmer. So to me, that's a wonderful world where the dull stuff gets taken out and the creative stuff gets escalated. So to me, this is nirvana. I'd love that world to come together. I think there'll be 10 times more programmers, but the word programmer will not require an education per se. Right. So that's my first point. To answer your second point, we are seeing lots of examples. For example, I'll just mention a few categories where machine learning is already starting to deliver value. Inventory management and optimization. H&M, I don't know if you've been tracking, $6 billion of wasted inventory because they were sending the same order to every store around the world, whether it was cold weather or hot weather. Now inventory management can actually decide that the store in Palo Alto should get specific number of items versus the one in Pleasanton. That's AI and machine learning. Robotics process automation, which automates all the back-end activities, which historically used to go to India and Philippines and Vietnam. A lot of that work can be done in the United States. So you can actually reshore work back from these countries because the machine can do a lot of the repetitive tasks. And then time series data analysis in the predictive maintenance in the industrial setting. When machines break down, extremely expensive, elevators stop working, buildings stop working, you can look at time series data and start way ahead of the incident, start predicting failures. So lots of interesting use cases starting to emerge with data.
Just to add on to that also, even not just the $1 million machines, we're looking at applications of predictive analytics to PCs that cost $1,000 or $2,000, right? So don't think it has to be this big industrial use case. That's clearly a place where time is money. But even for, if you're pushing out 30 million PCs, if we can make those last a little bit better, there's money to be made there for the entrepreneurs.
So I will introduce one of the areas that is becoming very hot within the AI space, and that is manufacturing robots and how you control the robotic arms. One of the companies that you can look up, his name is Osaro, O-S-A-R-O. It's based in San Francisco, and what they do, they are programming the robotic arms to be able to make decisions. So the teacher can show it that how to get things done. With a regular 2D camera, it is able to see what human being is asking them to do, and it can program itself for new objects, is able to move those things. Think about a car manufacturing country like Japan, where the automotive industry is pretty big. So they are going to be able to program those robots by itself. If there's an earthquake or something, it needs billions of dollars to reset and retune those pianos or the robots. And robots will be able to fix them itself and reset and do this. Some of the other companies that are coming in this field are Vicarious. Vicarious, most probably you are aware of that. Another company is Kindred.ai. These are actually replacing, not replacing human being. I will say that the people, where the labor is short, these companies are coming forward and actually replacing the human labor. So if you look at these three companies, Osaro, Kindred, and Vicarious, you'll see that every single top people in Silicon Valley, from Mark Zuckerberg to Elon Musk to Peter Thiel to Jerry Yang, everybody's an investor in these companies. So this is another domain I wanted to introduce to you.
So to quote one of our entrepreneurs, Andrew Ng, who's also a renowned professor in machine learning, he likes to say that AI is the new electricity and data is the fuel. So anywhere you have massive amounts of data, you have the opportunity to build a really interesting business on top of it, leveraging AI and ML. Historically, we were investors in a company called Climate Corp, which was the first to do this in the ag tech world, looking at weather and soil data. And just in the past 6 months, I don't have enough fingers on my hand to count the amount of companies I've seen doing really interesting things in predictive analytics and AI for manufacturing, for transportation. NEA is a very large investor in healthcare, seeing a ton in using AI and machine vision to enhance doctors. So I think we're definitely entering a new era for AI machine learning built on top of really large, interesting, unique data sets.
Okay, I think we're going to stop here and we're going to go on to the individual companies presenting. But if you guys have any last 5-second, 10-second comments, go for it now.
Yeah, so we think AI is going to be as transformational as the steam engine, printing press. So it's going to change our lives. Now that's the good news. The other cycle on that is printing press took 500 years to reach full scale, and the steam engine kept on morphing over 100 years. So I think every 10 years we'll look back at AI and say, wow, that was primitive. So this is a cycle which will extend beyond the lifetime of all of us.
Okay, thanks, guys. Appreciate your comments. And we ready, Stas?
Yes, and now our traditional startup pitches. So first of all, I ask everyone with the blue tag, all investors, come forward, take seat on the front row. You also judges. Every investor has the same vote. Our traditional voting, if you're not familiar, we have this 8 criteria we use to judge our startups. For each, you could put number from 0 to 10. Certainly 10 is best, 0 is not so good. Now, thank you to Google. Google provided us with pretty nice laptops, and this time we could use electronic voting for our judges on the stage. If something's not going well, we always could switch back to backup on the paper. And I also asked Google, you know, it's a Google, they know everything. They told me, you don't need it. You don't want it. Bring it back. Please, every judges, everyone with the blue tag, come forward to the front row. Now, this year we also offering everyone in the general attendance, not investors, to try yourself to check how well you judge the companies. We have application, check it in Apple Store or Android Store, keyword SVOD 2018. You could vote in public voting system. Later we'll using big data and machine learning and other smart technologies. We will compare your votes with the votes of the professional investor, and we'll let you know how well your judgment is, how close you are to professional investors. So it's not only startups competing, also aspiring investors competing in this electronic form. Okay, and now my pleasure to start this panel on machine learning, AI, and big data. And first company to present is DeepMotion. Please welcome DeepMotion. You have a clicker? Just a second, we need clicker.
Hello, everyone. My name is Kevin He, founder of DeepMotion. I'm honored to be the first presenter in the startup group. I'll try to make it interesting.
And you have 5 minutes.
So at DeepMotion, we are building a platform for motion intelligence. What market opportunity we are addressing? First, we are looking at global animation market. It's over $1 billion. Second, we are looking at AR, VR content market, also projected to be $100 billion level in a few years. The current solution to do animation in both fields are based on keyframe animation or motion capture. They are canned sequence frame, never change, static. The problem is extremely high production cost to produce an animated film. It's like it takes hundreds of millions of dollars. Second, the content is not interactive in AR and VR, which is a critical component to make it immersive. So at DeepMotion, we are proposing and we are building an AI for animation. Fundamentally, we run machine learning to learn how humans do our daily motions. Even a single hand wave like that takes 20 bones and 30 muscles to coordinate to finish. All the subtlety is very hard to be captured by keyframe. By using machine learning, we can do that. And we can scale to arbitrary motions we human or animals possess. The key architecture is a cloud-based machine training framework. The input are reference motions. They can be keyframe, they can be mocap or video streams. The output is something we call motion brain. That's the muscle and skeletal model to drive a digital agent to do that motion, just like how humans learn from our parents when we are small how to move around. So here some demo. The first example, we are learning from motion capture data captured from Vicon. A few seconds of dog motion are reconstructed in the digital world. Only 3 behaviors, sitting, running, and turning. As we add more and more behaviors, this dog will be coming out. It's fully interactive. You can drag him around. You can put a digital fly there, so he will chase him. So that is a high-end motion capture as input. At the same time, we can support low-end inputs such as a video stream capture on your iPhone. Like a dancer's low-quality capture can be reconstructed in the digital world to the blue robot that does a mimic dancing. You can use the blue robot as your avatar on your phone, in your game, in your animation film, what have you. So more examples follow. In all these demos, the green wireframe is the reference motion we capture from real human. And the blue robot is what we reconstructed using this AI. Even balancing on the ball, even tripping over obstacle can be emerging from this AI. So that's the amazing part. Once we learn from a few seconds of motion clip, our AI can create tons of derivative behavior, reactive behavior, interactive behavior, like this parkour motion. Take a 5 reference motion to build. Then you have a digital agent that can do parkour, jump around, jump down, that can replace a digital stuntman one day. Like this cross simulation, every guy has 3 behavior we learn, but the combination, the interaction between them are 30 behavior, 100. How do we compare to competitors like Google DeepMind? The directions are different. The right-hand side is DeepMind result at the end of last year. The style is more like creating a functional digital agent run from point A to point B. The motion style is arbitrary, it's not artistic. In DeepMotion, we also create a functional physics-based model, but it's also lifelike. It's like a real human, how we move around. Our belief is that by recovering the motion DNA from human, from our daily motion, we can take a short path. We can create the motion intelligence in the shortest future. The competitors here are most big game companies, AI companies, but the game companies focus on kinematic animation extension, and the AI companies focus on robotic behavior discovery. We are the only one who provide lifelike, functional physical model from AI. We are currently in closed alpha in the first half of this year, and we are looking to launch our cloud-based platform in the second half of this year. Just a few more use case study. The left-hand side is example for animation studio cost reduction. That's a VR game based on Walking Dead, a VR game. You usually spend thousands of hours to do all those zombie animation. But once our AI reconstruct the physical model, you can tweak the muscle strength, tweak the joint angle to make all kinds of like zombie movement around. The right-hand side is an AR demo using Apple's AR kit. It basically, once you have the physical model of the motion, you can drag the dog around, you can throw a stick to it, you can play tug of war, so it becomes 3D, it becomes truly live. So that's why we're thinking in AR, VR, we're enabler tech to make the character truly interactive. And in traditional animation, we make a tons of derivative motion to reduce the cost. So our business model is to sell behavior as a service. We'll give everyone a free 6-pack man that's like a blank digital robot that can move around. Then you keep loading behaviors into that blank template to have jumping, dancing, gymnastic move, what have you, and we sell that behaviors. Those are intelligent behavior reconstructed in physics simulation format. The team came from leading game companies, animation companies, and we have combined 50 years experience in the industry and academic. Our lead scientists published 8 secret papers. We have 1 patent filed, 2 patents in pipeline. It's a world-class team, combine the best expertise from animation, AI, robotics, and AR. So we want to deliver this motion intelligence. Google coined this term called
Thank you. Time is up.
Yeah.
Thank you, DeepMotion.
Yeah. Thank you. Feel free to send any questions to me.
Now questions from our, no, stay, because now it's most funny part. No, not from audience. Questions from judges, please.
Can you tell us a little bit more about the barriers to entry? You know, how are you able to create this automatic AI animation? Is it you have a unique data set? Is it the software? Do you have patents behind it? Would love just to understand a little bit more about how you prevent some of the other big names up there from catching up with you.
Yeah, first, the team has we each individual have been in this for over 10 years, research, industry experience. We came from diversified background from gaming, film, and AI. So it's a unique combination and world-class expertise in the team. Second, we're using deep reinforcement learning as one component of that framework. So it's not, the jumpstart data is not data hungry. We can start with 1 or 2 reference motion. We run a high-fidelity physics simulation to do thousands of try and error, just like how young baby learns motor skill from the adults nearby. So that direction is unique. And our vision is that by learning from human, learning from millions of years evolution, we can reduce the problem space greatly. We'll grab that AI fast. And we have something already working. We have patents in pipeline to protect IP. So hope that will answer the question.
More questions from this side?
Why are you going after AR? It's an unproven market. It's very small. It seems like an animation. There's a big market. There's pain. Companies will pay you because you're going to save them money today. So tell me why AR?
So I think Team Draper this morning have a good quote. I agree. When we build a startup, we also build a vision, the vision in the future, 10, 15 years. So animation is the current market. That's right. That's, a lot of our alpha users are from animation industry. But AR and VR, I believe, is the future. So that's like our projected market in 3 to 5 years. And we'll be there, be the enabler tech for interaction, AR, VR, when it's ready. But we're not ignoring animation industry as the core.
A question from our jury tables. Yes, please.
Two related questions. One is, do you have paying customers? Two, what market segments are you going after first?
Do you have paid customers, and what segment are you going first?
Yeah. We are pre-launch, but we have over 200 alpha users. A few of them are early adopters. Some of them even paid, so we do have some initial customers. They are some of them are AR, VR platform or mobile companies are big. Some of them are just indie and game developers. What's the second question?
Could you tell us what your go-to-market strategy and what market subgroups you're going after first?
Yeah, the market target audience are developers. We are counting like 1 million animation developer, animation designers as one part, and there are also 2 to 3 million potential AR, VR content developer from the app group. So combined, there are a few millions of developers related to animation or interaction. So for those a few million users, we'll give them default physics model, like a six-pack man move around, and they will purchase behavior as a service from our cloud. And that's just converting machine time into a tangible digital assets we sell to these developers. So that's fundamentally is a SaaS model we are using to target this audience.
Thank you, Deep Motion. Let's thank everyone.
Thank you.
Thank you. And before we're moving to the next, Google Works, okay? New toy from Google. Do you handle voting? Oops. Yes, it's work. If something wrong, you always could go back to paper. It's worked for 2,000 years, maybe 3,000 years. Okay, the next company is Chrome. Chrome, please. Please change presentation. Yes. Chrome.
My name is Igor. I'm a founder of Chrome. Do we have any software engineers in the crowd? No? Really? All right. This is for you, my friends. All right. I'm a DevOps guy myself, so let me show you the pain of a job search nowadays. So there are old timers which encourage you to upload your resume. You don't want to do that. You'll get spammed. This is plain and simple. There are some websites that try to estimate your salary. It's not even close to what we make it nowadays. There are some popular websites like LinkedIn and ZipRecruiter, and basically the results that I'm getting is just too many. And it's a lot of homework to go through this list and select the companies that I'm actually interested in. So the normal homework looks like this. So I need to see if it's a public a private company, the growth, and the main question is what they're going to pay. So let's flip the coin and take a look at this from the company's perspective, especially smaller companies, A and B series. Those companies, it's not easy for them to find good candidates as well. Those companies also get spammed by recruiters, and recruiters are very expensive. They normally charge 15 to 25% of the annual check of the candidate. So basically the problem is we have a bunch of companies who are looking for good candidates, and we have a bunch of good candidates looking for good companies. So what do? We create a rating system. We're going to index and estimate each company, how good is it, and we're going to index each candidate to see how good the candidate is. So we do this by basically pulling public information from the websites, and we crunch this data using our algorithm, and we come up with a rating, and if the rating matches the company and the candidates, that's a good match. So what is a good company? So those are some parameters that we consider when we index a company through algorithm. And we also do a similar job for the candidates. We estimate how good the candidate is. So here's the product. Basically, we're building this product for the companies to make their life easier to hire people. And companies are paying the bills. But we need to make the website attractive to the actual people who use it. So it looks like this. It basically encourages you to drop your resume, and we'll give you an estimate of your salary. It's almost like a game. I would just do it out of curiosity to see what happens. So bang, you get a message with the exact amount, how much money you're supposed to be making, and the short list of companies that would be interested in you or would be interested to you. So the rating system is the core of our engine. Basically, we tune this system on every iteration, and we use a combination of human and machine learning. It's similar to basically a Google ranking system for the websites. This rating does not have to be static. We can make it dynamic and adjust, personalize it for each candidate. So what do we have so far? Well, ladies and gentlemen, top 5 companies for a DevOps engineer in Silicon Valley nowadays. The prototype is running on the website, and feel free to take a look at it. So what's the plan? We want to be very focused and very specific. We only target high-tech companies of Bay Area, specifically A and B series. Our fee is only one paycheck, which is about 4% of the annual salary. And we're building this whole engine based on virality, because we want to make it popular. Thank you, Tim Draper. And let's take a look at the market. This market is huge and very lucrative. The average turnover in high-tech industry is less than 2 years now. And this is true. I do it myself. So it's an insane number. Let's take a look at the recruiting fees. So what's this number? 15 to 25%. I mean, this is $40,000 for a few phone calls. This is insane. So this industry is basically waiting to be disrupted. Thank you.
Thank you. And now questions.
I have a question. How do you prevent and how do you know that a candidate has been accepted by an employer and therefore you should collect payment because you would have to send it to them first?
Correct. We pay the applicants $1,000 as a fee if you land the job through us. So in exchange for this, I'm getting the job offer. I need a copy of the job offer. That would be proof. That also shows me the salary, which is important.
Got it. Thank you.
What's your go-to-market, right? It's very hard to develop a two-sided marketplace. How are you going to seed the market?
Well, similar to what Facebook did. We want to make it useful for 10 people. If I can make it useful for 10 people, I can scale it. I can make it useful for 100 and so on. But it's not that easy to penetrate the market. Basically, you start really small, make it usable for like 10 people. I need to find a job for like 10 of my colleagues or ex-colleagues and go from there.
How many people do you have in the team today?
I have a group of developers in Siberia, and on the US side, it's just me, myself. and I'm looking for a good recruiter co-founder. So please ping me.
You mentioned your initial market was Series A and Series B companies. I have a question if that's sustainable long term. So how do you think about expanding beyond that initial customer market and where else you'll go?
This is just the beginning. I need to penetrate. I need to start somewhere, basically. If that is successful, basically the bigger companies have HR and recruiters on staff. So it's difficult to compete with them. But if I show that my engine is better, then they will just come. But same goes to the industries. So I start with high tech because I know this industry very well. But yeah, of course, I want to expand to other.
Question from the jury, please. Just use microphone.
Can you talk a little bit about your proprietary technology? What do you use that the dozens of fairly big and successful recruiting companies can't get from the resume? Because at the end, the applicant just gives you a resume and presumably it's accurate. But that information is available to many people. So you're suggesting you actually get some data from that others can't, and with that you offer a better match. Can you explain that a little bit more?
Not exactly. I'm basically copying what a human being does. Like if I give you a copy of the resume, how do you know if this guy is good or not? So you take a look at certain parameters. What kind of education does he have? What kind of companies he worked for? And some keywords that like show you the potential of the candidate. So I want to do the same in the computer algorithm. That's all.
Okay, one more question.
This is a really old market with many, many competitors. Do you have any evidence that your outcomes are better than other technologies, other approaches?
Not yet, but the statement that there are so many competitors, it's like we used to have lots of search websites before Google. There should be only one winner, really. There is no leader in recruiting right now. Like when I'm looking for a job, I don't have a good website to go to. That's how the problem started.
Yes, last question.
Yeah, there should be a back-end metric of how long the candidates stay placed in the new company as a reflection of how good it is.
It's less than 2 years now. It's not the reflection of how good. Some people are really good, but they still change places. It's just the nature of Silicon Valley. We're not looking for big companies. I don't want to work for Google or Apple. I want to find the new Google and basically grow with the company and become a millionaire. That's the goal. And we're looking for stock options. And usually after like a year and a half, it becomes clear if the company is on the right path. If it is, you stay there. If not, you kind of start looking for other places. That's just the nature of it.
Thank you. Thank you, Kroll. Yep. And now we have BioLink Tech. BioLink. Voting works. Everything. Google. Good. Do you like this toy? Okay. Here is a clicker. BioLink. Okay. Let's welcome BioLink.
Hi, guys. My name is Evgeny Cherishnev. I'm founder and CEO of BioLink Tech, and we're in business of what I call profitable privacy. In 2015, in order to truly understand the potential of the Internet of Things, I implanted myself with a biochip. Basically, yeah, it's weird. It gave me a unique understanding of what the future of data and machine learning would look like. As soon as I understood the true potential, I quit my well-paid executive job and just focused on what today is known BioLink Tech and digital DNA. Because what is human DNA? It's just a blueprint to our bodies. It contains physical information about certain hate or you have predisposition to obesity. By comparison, digital DNA is approximately 42.7 terabytes of lifetime behavioral data that is in fact the blueprint to your psychology. When you have someone's digital DNA, you actually can tell that this person A will do in situation B with probability C. And everybody has a digital DNA, a human being, a company, or even a country. Now the problem is that the digital DNA does spread through the network because most businesses right now, they try to rip off a chunk and monetize it. As a result, users have hundreds of accounts that eventually get hacked, whatever the effort. And usability sucks. And cybersecurity costs skyrocket and they're not helping anyone. Plus, fair competition is being destroyed as we speak because companies with vast amounts of data like Facebook, they end up owning certain markets and artificial intelligence R&D, which is not okay. And privacy has become a luxury product because we right now estimate that it costs up to 30 grand per year to maintain your privacy with the help of a hired specialist and dedicated software, and all has to stop. So our product, we think, is a game changer. Essentially, it's a private digital DNA embedded in the form of an unprecedented wearable computer. It does three things. First, it gathers information about one single individual and his surroundings. And that means gaits, retina scan, heartbeat, voice, real-time air pollution and radiation data, information about behavior in traffic, information that Google and Facebook and other companies right now are bound to give to the users according to GDPR, and many others. Second, this, I mentioned traffic, sorry. Second, it stores this data in a very secured P2P form, so even with the company, we don't have access to it. All the trackers and all the advertising networks, about 2,000 of those, they're cleaned from the traffic with our Firelink VPN. And third, actually, the private artificial intelligence that lives on an endpoint, it actually empowers the user to use this data. Digital DNA is used for multi-factor biometrical identification, medical, banking, insurance, purchasing, and other types of dynamic scoring. It's pretty much self-explanatory. Essentially, what BioLink is, it's a private version of Android and iOS with pretty similar functionality. You can pay for stuff, you can store your memories, you can securely communicate, you can do everything with one major difference. The difference is at all times, all your data, all your digital trail, all your scorings, all your private artificial intelligence, they belong to you and are with you at all times. And basically, no third party get access to your data like it is today. What they get is a subscription to access your digital DNA on your device, under your rules, provide your service, and get paid. And this cuts their expenses to data management tremendously. So most players right now, they have data sets on their customers, but it's very fragmented. Some of them have social media data, some have purchasing data, some have fitness or medical. What we offer, we give the users their unique, very complete and specific data sets, digital DNAs, that they can benefit from. They're too detailed and boosted with private artificial intelligence algorithms, so it finally becomes very interesting for the brands to interact directly with the BioLink users without any middleman. We are actually not a companion device. We are a new category with smartphone-grade hardware power and a gesture interface. In the future, of course, we're going to make BioLink smaller and get rid of the screens completely. There is a roadmap for that. The size of the market is approximately at least $300 billion based on our estimations. And it was saying that we're not a hardware company. It's inevitable evil we're doing. Our revenue comes mostly from a subscription model, from bundling with ISP providers where we charge for privacy and unique private intelligence services that are built on your unique data sets. Right now, today, we have more than 2,000 leads. Qualified leads to people who are ready to buy the product. We have 2 letters of intent from really large networks of retailers. We have interest from 2 European banks and interest from really large state-level enterprise. This is our current market evaluation. So up to today, we've raised $1.5 million in UK. We filed 4 patents and 18 pending. And right now, here, I'm solving 2 problems. First, I need another 1.3 million to get to revenue early next year. And I want to find a partner for approximately 50 mil Series A round. Right now, we expect that early next year, we're going to get revenue and really want to be at least 60 mil per year company in 2020. Right now, the team is 17 high-tech specialists, mostly data management, AI, cybersecurity. Our HQ is in London with R&D centers in San Diego and Moscow. And we have a very experienced executive team with previously successful exit in their resumes and a tremendous network of advisors, government support, and private investors in Europe. But as the US market is key to our scaling, we decided to invite US investors on board alongside with the European ones. The team is very committed to the mission. We think that when private property for data and privacy would become a new thing, we would see an explosion of new business models, because what's going on, it's not okay for anybody. We truly
Thank you. Time is up.
That's basically it. Yeah.
Question.
Could you? Yeah, could you tell us a little bit more? Who is your ideal customer? Is it are you selling to consumers? Is it a business? What types of businesses?
It's a very good question. The truth is, the ideal customer is business. So I want to do the enterprise play. The trick is, in order to get there, I need to bypass the stage of pretty severe customer research. So I'm doing the B2C thing with real customers just to understand what I'm selling in more details. The verticals that we are right now exploring, they're medical. We have a potential interest from a big pharma company that are interested in purely medical application. Banking, finance, insurance, and smart grid, which is smart city. We're narrowing it down to those. And right now we're just trying to use our resources wisely, not to disperse them too much. So we're doing it, step by step. But initially, I want to be purely B2B.
Okay, more questions from here. Questions from tables. Yes, please. Just a second, wait for microphone.
I understand you're going B2B, but at the end, it has to be B2B2C.
Correct.
So what evidence do you have that, given the amount of data you're gathering, consumers will actually adopt this, even if it is within an enterprise?
So it is a very good question, and I started with that. So my Facebook actually, well, it's inevitable for me to be on Facebook, unfortunately, is huge. So I have 5,000 followers, and I'm a pretty, public figure with all the TED Talks and stuff. So the first thing I did, I addressed like one by one specific people, approximately 3,000 of those, and asked specifically, if I'm giving you this, and this is how it works, how much would you pay me? Would you pay me at all? And basically, that was the first evaluation where I just decided to start the company. So I have physical proof that there are real people who say, okay, if you give me the proof that you do not leak the data to third parties, I'm ready to buy that. And if it's in fact true that you basically train your machine learning on my personal data sets with, of course, there is some expertise involved from external market. If you prove me that it's basically mine and I own it, it turns out that this egoistic desire works. And I get like pre-orders, so to speak, right now. I hope that answers. Because it cannot be purely B2B at this stage. You're right. It's a mix.
I have a quick question. Who you think are your competitions today?
I want to say Google. Well, seriously speaking, of course we compete with everybody who is doing a wearable because there are only two hands. But the trick is, the way I see it, most players, they are bound by their very focused niche business models, like Fitbit, for example. They're doing a very specific thing. So in that sense, for us, it's easy to replicate fitness. It's not rocket science. But what I'm aiming for, just think about it. If you have dynamic scoring of a human being, and you have, let's say, dynamic scoring of a business, let's say it's Walmart, whatever. At a certain point, you can bypass, you don't need advertising. You just basically interact with them through API. This is exactly what I mean by Google. I'm not saying we're going to win or whatever, but this is the goal. We really want to challenge Google and Facebook, honestly. Okay, you squeezed me.
Thank you, Baehr. Thank you. Thank you.
Thank you.
By the way, all our startups stay with us during lunch. You always could meet them and have more questions. Now, before we're moving to the next company, I like our jury to introduce themselves. Do we have mic for table? Who have a mic? Please. Let's do table. Table, 20-second reverse speech. Who you are, what you invest, what is your focus?
All right, Lilia Sherman, I'm a managing director with Golden Seeds. I'm an angel investor and focus on enterprise and B2B tech.
Jay Bodu, I'm VP of New Products at Juniper Networks and also a visiting scholar at Stanford University focused on machine learning and AI.
Roman Gluchowski, Andre Capital. We're a new billion-dollar fund that launched a couple of months ago, and we do late-stage technology growth with a little bit towards earlier stages. Thank you.
Brad McManus, Managing Director of Motorola Solutions Venture Capital.
Vitaly Golem, Managing Director, IAG Investment Banking Group, San Francisco office. We do Series B and beyond and M&A and seed investment globally.
Thanks. Harry Dixon with Flint Capital. We're an early stage venture fund, 1 to 5 million checks across Tel Aviv, Boston, and Palo Alto.
Sherry Chuang, investor at Sandhill Angels. We're a group of 100 members and invest in enterprise, consumer, and health tech. I personally invest in IoT and enterprise.
Mark Lockriff with ClearPath Partners. I'm an angel investor in B2B SaaS services, and I'm also on the investment committee of a venture firm in Europe called Black River Ventures, where we focus on Series B cross-Atlantic investing.
Saffir Ashi, I'm Managing Director of Think Plus Ventures, a new venture firm focused on seed stage, on consumer, digital health, and enterprises.
Hi, my name is Priore. I work with Think Plus Venture as an associate.
I'm Geoffrey. I'm an angel investor and also a venture partner of SkySea Venture, which is a $200 million cross-border fund investing in startup focusing in China and the U.S. market. And previously, actually, I founded a Lab 360 hardware incubator. So I'm glad this panel will talk about 55 hardware startup companies, because I actually don't believe it's all going to be future. It's all going to be software. I think without the hardware platform, software needs hardware platform, new hardware platform to accelerate.
Hi, I'm Nancy Hayes. I'm an angel investor across a wide array of sectors, and I focus on women-led companies.
Hi, my name is Nathaniel Krasnov, and I'm an investor at Wildcat Venture Partners. It's an early-stage generalist fund in the Valley.
My name is Elisa Yaffa. I'm an angel investor and advisor, and I invest in different industries, whatever I think is an opportunistic thing to get into that I understand. And I'm also the managing director of Step Up Funding, and that we invest in early stage and Series A and B rounds.
Hello, I'm Jordan Wabe, managing director of Baehr Angels. We invest in enterprise, B2B, and some B2C seed, some early stage Series A and the like.
I'm Ron Weissman. I was a VC for almost 20 years with Apex Partners. And for the last long time, I've been running the software group for the oldest angel group in America, the Band of Angels. And I'm also on the board of the Angel Capital Association.
That's pretty good. I'm Stu Saffir. I conduct technical due diligence of startups for investors. My background works in computer science and intellectual property, and I've angel invested in cybersecurity, IoT, and augmented reality.
This is Harry Feng. I'm a partner with the Fusion Fund. We invest in early stage, deep tech, and enterprise. Thank you.
I'm URI Savitsky, the founding partner of the Startup Accelerator Integracy Group. By the way, one of our startup is here. We did seed investments. The name of the startup, Behender, it will be tomorrow, the pitch session of the startup. My background is software and cybernetics.
Hi, I'm Cameron Turner. I specialize in AI and machine learning. I'm a co-manager of the Oxford Angel Fund and a venture partner with Spike Ventures, Stanford's angel fund.
Hi, I'm Maya Varda Shishani. I represent the Bird Foundation, a U.S.-Israeli R&D fund. We invest in joint R&D projects between Israeli and U.S. companies and provide non-dilutive funding.
Thank you. And I hope all our investors will stay with us for longer, and entrepreneurs who took notes will approach you and chat. Now, next company, Helios Wire. Let's welcome Helios Wire, please. Can we have the right presentation? Yeah.
Yeah, thank you. My name is Scott Larson. I'm the CEO of Helios Wire, and we're building out a satellite-powered, space-enabled Internet of Things network. This is actually my second space startup. The first one was a company called EarthCast, which we started in my basement up in Vancouver. We signed agreements to put cameras on the International Space Station. We scaled it up. We took it public. We raised a couple $100 million. I was the CEO. I stepped down 5 years to the day from when we started. EarthCast wasn't a big company, 250 employees. Last year did about 45 million in revenue. Its peak market cap was about 500 million, but it wasn't a startup. And I wanted to get into another startup. And a week after I left, I got introduced to this Australian company that had a business plan. It had started 4 or 5 years before to monitor cows. And the thought was you could put a tag in a cow's ear, powered by some kind of kinetic energy. The location would go up to space. You could track it by satellites, and you could cut down on cows getting lost from space, which is an interesting idea. Australia's got 30 million cows, huge farms, but back then the satellites would cost $500 million. So interesting idea, but you could probably hire a university student to follow each cow around and it'd be cheaper than trying to do it from space. And so the company kind of waffled, and I spent 4 or 5 months going back and forth with them. And at the end of the day, we all agreed, this isn't animal tracking, although that may be a good application. This is the Internet of Things from space. And what we're trying to do is take a technology that up until now has only been available to governments and kind of Fortune 50 type companies, and see if we can go down into the B2B portion of it and eventually democratize it. Take a technology that's only been available for a few and scale it globally. And I'll come back and talk to this about in a minute. Basically, what all this means is that we have spectrum. And spectrum is the right to send data from Earth to space. It's given to us by the United Nations. It's hard to get, extremely rare, incredibly valuable, and we have a huge allocation of spectrum, S-band in particular. And so the business model is to build out little tags, some of them the size of a shoebox, some of them the size of your phone, that truly just beep information to space. Whatever data you want, location, elevation, temperature, they're solar powered, they're independent, they're stickers. You can attach them to things, hook it up to other sensors, industrial, agricultural, shipping, supply chain, whatever it is, and the information truly just gets beeped to space. And if you have one satellite, it'll pick it up every 12 hours. That's kind of how the orbits work. If you have 2, every 6. If you have 4, if you have 30, every 15 minutes. We have enough spectrum to track up to 5 billion devices on the ground for maybe $1 a month, so it's hugely scalable. Here's where we are right now. We're based in Vancouver. We have 3 satellites scheduled for the next 12 months, 1 going up this summer, 2 going up around Christmas time, and then we'll phase the rest of the constellation as revenue comes in and as the company scales up. And that's just kind of the point of new space, is you can spend CapEx as the company scales up. Here are the satellites. They're not particularly complicated from a space standpoint. They're being built for us down here in Silicon Valley. They weigh about 40 pounds. They cost about $2.5 million to build. It's another $1 million or so to launch. So for $3.5 million, you have a satellite designed, built, launched, commissioned in space, generating revenue. We fit into the IoT industry, Internet of Things. No one really knows how big it is. It's $1 trillion, but when you narrow that down to what portion of that comes from space, it's actually relatively small. The Internet of Things industry right now from satellites is about $2 billion a year. So it's kind of a niche market, but there's only 5 companies participating in it. Each of them have spent billions of dollars building their constellation. And when you spend billions of dollars building the satellites, your whole point is to try to charge more. So the average cost of a satellite-connected device right now, IoT device, is about $400 per year. It's kind of like the cable companies here in North America, where you already have 150 channels. They keep giving you more channels so they can charge you more cooking, more sports, more shopping, whatever it is, so they can charge you 150, 175 for your monthly cable package. And then along comes the Netflix, which isn't trying to charge more. In fact, they're trying to charge less. And so in this particular case, when we look at this industry, with the average cost of a satellite-connected device at $400 per year, and we're coming in with a device that costs $20 or $30 per year, what percentage of this market do we think we can capture with something that's just purely good enough? It's not the top of the end. It's not streaming video. It's not satellite to cruise ships or things like that. It's just kind of a good enough type service for truly 5% of the cost. What portion of the market do we think we can capture? We think we can capture 10%. And then we think we can capture a much larger portion of the growth in the market as it scales up. Here's where we are. We've raised about $7 million. We have the launches booked. The technical design is done. We're spending most of our time right now building out the revenue pipeline and the ground segment. So far, we've got about $35 million of annual LOIs booked from distributors and customers and systems integrators, who is the top of the revenue funnel, and we'll continue to put more of that into the top and then convert those from LOIs and MOUs into conditional contracts as the satellites go up. Thank you very much.
Thank you. And now time for questions.
Yeah, I had a question. Looked at Sigfox and companies which tried to build networks, and understand global coverage, impressive on the satellite side, but how do you build ground coverage of all the meters? Because that's where the friction tends to be. So you may end up with the supply on the sky side, but getting enough customers who are willing to trust their metering to you. That seems where the cost tends to be.
Yeah, so we're building the backhaul. So we're building a device that hooks up to the Sigfoxes, the LoRa's, the NB-IoTs, all the LP-WANs out there that are trying to solve the last mile. So there's a sensor that's sensing data, whatever it is. It's tracking pipelines in Africa. It's tracking containers as they leave the factory in China, whatever it is. There's a sensor. There's a little tag that takes the data from the sensor, and all kinds of other companies are trying to solve that problem. We're building a little unit that plugs via Ethernet into their IoT gateway, and we provide the backhaul. So we extend their reach into areas where there isn't cellular, or the infrastructure doesn't work, or it's dangerous, or it's just socially awkward, whatever it is, and we provide the backhaul. The data goes from thousands of sensors to the satellites, back down to the ground, uploaded to the cloud, and then we wrap it into whatever kind of analytics the customers want.
How do you avoid commodity competition if all you're doing is backhaul bandwidth? In other words, if the moment people realize, it was a very thoughtful presentation and I love the business plan that you presented, but what stops someone else from jumping in?
It's the spectrum. I mean, getting the rights to send data from Earth, that is the underlying asset. Spectrum is incredibly hard to get. It's a long story of how we got it, but spectrum is essentially all gone. And so there are companies that have little slivers, and they're trying to divide up spectrum, and we can monitor the northern borders of Canada or the little small areas. But to get a global spectrum filing is virtually impossible. It is impossible. And we, for a variety of reasons, have all of it, particularly in S-band, which is good for ping. So you can come up with business plans. If you don't have the spectrum, you kind of go to jail.
So why is your CapEx so much lower? Is it just a timing, the fact that these companies were built 10 plus years ago and the cost to launch a satellite has come significantly down? Is there some innovation in the way you're using the spectrum in terms of getting a higher bits per hertz? Or would just love to understand a little bit more about where that special sauce is.
Yeah, it's timing. I mean, 10, 15 years ago, people were all going after broadband, satellite TVs, internet to cruise ships and planes and things like that. So they're building satellites that cost $300 million. They cost $60 million to launch, and they're putting all those geostationary satellites up, and the CapEx is enormous. And so based on new space, you can build a satellite that costs a couple $1 million. It'll last for 5 or 6. It's low, of course, and that's essentially it.
So I've got one question for you, which is the devices are usually where the people are, and the cellular networks are usually where the people are. And I was just talking to the guys at Verizon, and for them to do IoT, it's a software load, NB-IoT or LTE-M, and they're up. So our belief is that the Sigfoxes and LoRa's and all that, it's all CapEx junk. They're all going to fail. So realistically, though, the devices are where the people are, and the people are already covered by cellular networks by far and away. So how do you get outside of that, the density of the customer devices is really low. So how do you build a business model saying we're really going after something that the cellular guys can't cover, that the existing telemetry guys can't cover, and we're going to slice the number of devices by whatever application needs this type of connectivity? How do you build a business model around that? I'm not being critical, I'm just asking.
Yeah, I think if we were trying to track people, that'd be the right question, except we're not. We're trying to track devices in the most remote parts of the world. So as an example,
I'm saying is the devices are usually where the people are.
Not necessarily. If you put a tag on a container as it leaves the factory in China, you track location, you track vibration, you track temperature if it's sensitive, and you track if someone tried to open the lock or open the door, and it tracks it from the factory, it tracks it to the train, across the ocean every few hours, pinging up data. Nigeria loses $3 billion of oil per year in the most remote parts and difficult parts of the world. And so you put sensors every couple of 100 yards that track noise, and they track vibration. And if these things pick up noise, it means someone's backing up a tanker, they're going to stick in a screwdriver. So that's the type of thing. Satellites are good for things that are remote. You're not going to use satellites for your connected appliances or your Nest. It's for things that are remote.
Okay, thank you. Thank you, Helios Wire. Please, judges, and our jury, please don't forget to put your numbers. We will enter in the system we need it. Before we moving to the next company, I'd like to thank person who tremendously helped our startup to prepare their presentation to bring this presentation to the shape acceptable to Silicon Valley. Thank you, Donna Griffith. Where you? Wave. So if you need help with the presentation, my big recommendation, Donna. And now it's pleasure to invite Aromics, sensing and artificial intelligence to digitize and sense a smell.
Hold on to that for
Last, yes. Aromics. Let's welcome Aromics.
Got it. Thank you, Stas. How do I go forward? Everyone, about half of human perception is based on our sense of taste and our sense of smell, and yet we've never applied technology to our sense of smell or our sense of taste until Aromics. Aromics is digitizing taste and scent. We've essentially invented the camera for taste and scent. I'm Chris Hansen. I'm founder and CEO of Aromics. Aromics has invented proprietary sensing technology, software, and artificial intelligence to measure and digitize taste and scent and to be able to edit it and work with the resulting data. We have 5 senses, our visual, auditory, and touch. We've understood those for a long time. Those have been measured and digitized. We've applied technology to them. That kind of sensory data you can find on Google, but not taste and smell data because it's never been measured before. There's never been a way to measure it. The state of the art now for industry is to use humans, consumers or professional noses to smell or taste something, and they write down in words what they've experienced. It's famously irreproducible and unscientific. We used to do the same for color, but then in the last century, we started applying technology to visual data and to color. Now we have RGB coordinates, and we think nothing of editing a color or even editing a video on our laptop. We need something like that for taste and scent. We need Pantone for taste and scent, or we need Adobe Photoshop for taste and scent. And that's what we're doing at Aromics. Not an e-nose or an i-nose, it's the actual nose. You have about 400 olfactory receptors in your nose. We start with the DNA, we clone those into a biochip that we call the Essence chip, and it's essentially the nose, and we'll follow that with the receptors for taste. So we have a nose and tongue and a biosensor. Every time you measure Coca-Cola with that, you get the same digital readout, you get scientific reproducible results. And we've fielded an entire platform with software tools, with a family of visual analytics, and are now applying AI to the resultant data. And we're creating the largest repository, the largest marketplace of taste and scent data. So how it works, you can take an ingredient or coffee, Coca-Cola, Chanel No. 5, or the byproduct off-gassed by some industrial process. You expose it to our plate, either gas or liquid sampling, shove the plate into a standard piece of lab equipment called the plate reader, which reads the output of the receptors from the nose and tongue. And then we offer a software as a service and a digital marketplace to work with the data. We're applying this in biologics drug manufacturing, oddly enough. It's notoriously difficult to make biologics, and yet the manufacturing personnel said that sometimes we can smell when things are going bad or things are going really well. So we're applying it there. We are also starting to look at tobacco and automotive, and those are the 3 verticals that we're focused on. Indexing every taste and scent to create a marketplace, a central repository of taste and scent data that's proprietary to us and from which we can extract valuable insights. We make money by selling the sensors and by selling the data. We have a very experienced team. We're alums of IBM, HP, AstraZeneca, SRI, UCSF. We have some 5 bio PhDs on the team and some 15 bio PhDs associated with Aromics as advisors. And we have a monopoly on the data. We have proprietary sensing technology that produces unique data. We have a lock on that. We have a choke point on that. And I think over time, we will be selling sensors, but I think the data is going to be the main part of the company. We have traction with 2 of the largest companies in the world, a large pharma company and a large tobacco company. And we're in negotiations with one of the largest auto companies in the world. Thank you.
Wow, very interesting. Now questions.
So you are developing the sensors, or you're also developing the system, the card reader?
No, we don't make the plate reader. 20 or 30 companies like Thermo and Agilent make plate readers. We found that all of our customers and all of our prospects already have plate readers. So we're not in that business. What we make is the goop that goes into the biosensor, and we've tried to invent as little as possible outside of the goop that senses the taste or the scent.
Can you give some characteristics of the sensor? What is the cost? What are the gross margins? What is the time to sense, failure rate, etc.?
The cost, I won't go into the cost, but the price is $1,200 a piece, and they're a one-time use sensor. And so that's why we like verticals like pharma and tobacco, because they don't quibble. $1,200 per use is fine. Your other question?
Just some characteristics. I mean, I didn't realize the price point is that high per use, so that implies that you have, very low failure rates and specialized applications as you described. I'm not going to, just do it to taste the dinner that I made tonight, just for the fun of it.
Well, we thought, originally we thought we'd be working with Pepsi and Coke and Kraft, and it turns out that they're very price sensitive. The margins there are so small. And a lot of those companies no longer have any kind of real scientific bench. But pharma, tobacco, and auto has a deep scientific bench usually. So there are people we can work with, and they're price insensitive.
I have another question. So you mentioned auto. So what is it that you're trying to do in the automotive sector?
Auto is a really interesting application. It is essentially the casino or the retail store application. So years ago, casinos started manipulating the odorscape. A friend of mine, Alex Hirsch, a noted academic, was the first one to do this for the casinos. And Alex is now a multimillionaire. He's no longer an academic. He's a casino exec. But they found you could uptick the take at the slot machines by 50%. By just trial and error manipulation of the odorscape. And that has spread to Neiman's and Saks and Abercrombie & Fitch and Nike. So a lot of retail stores do that to increase spending behavior. Automobile companies, Steve Jurvetson was here this morning. He said, we're going to have autonomous vehicles. All the car companies are absolutely sure of that. And they've all told me, we won't have drivers, we'll have passengers, we'll have shoppers. We want them to go into the dashboard shopping portal and buy things. So we want you to give us profiles of odorants to pump through the cars. This sounds a little creepy now that I say it, but to influence customer behavior. So you'll have 10 minutes of maxed out shopping behavior, and then maybe 5 minutes of spa, and then 5 minutes of alert, and then they'll push you back into shopping behavior. And for that, we're negotiating either a per seat, per vehicle license, like a software model, or value pricing, where we would get a take of the spend.
I have a quick question on the business model. You mentioned you were going to sell chips as well as data. Do the current contracts you have with customers allow you to sell their data to others, or would help to understand a little bit more about the how you actually going to monetize or move beyond just the chip business model?
So at this point, our first customers allow us to own the data. We haven't insisted on that, but we've heavily incentivized it. And in the future, we may just insist that the data belongs to us, but could be licensed back.
Thank you, Aromix. Thank you.
Thank you.
Good luck. Now, dear jury, please put your names and names of the company you review on the H sheet. We need this to enter into our system. And now, please, judges, 30 seconds each table. Discuss between yourself what company you find the most exciting among those 5. If you have, just, I hope you will agree, but yes.
No, I thought Aromix was a great idea. If they could get the sensor cost down, it would be an even better idea.
I think Aromix and Helios were interesting. I'll talk to both of them personally.
Okay.
I liked Helios Wire the best.
Helios Wire.
Yeah, for me, it was Aromix and Helios. I think Aromix has a fascinating technology, some questions around what the ultimate market is going to be. Helios, just a well-articulated presentation.
I'll pick Helios as the most interesting presentation because it is, I would go so far as to say that they're almost guaranteed to win in the sense that they will be a company created of some size. The only question is how big can they get?
Yeah, I like Helios, although I have some concerns whether on the ground meters they'll be able to scale that side of the business. I think they'll build a complete full stack, and I think they'll get acquired. I actually like DeepMotion, the animation company. I do worry if Pixar cannot match it, but there's a long tail of animation companies, and Unity has proven that you can build a 3D gaming engine of huge value, and if they can create a Unity-like experience for animation, then I do think they have a real opportunity. So.
Okay, thank you.